Okay, everybody, this is chapter 4, section 5. We have a bunch of theorems here to kind of start us off with. This is kind of dealing with some specific things with specific triangles. So we'll have to identify or define certain terms here that maybe some of you have not heard or seen or worked with yet. Okay. So once again, let's not worry about writing. Let's not worry about writing the theorem number here. A corollary is kind of an addendum to a theorem. Okay. And in this last one too, it's kind of like you have your biconditional statement to start with, but then it's the converse of that follows it. Okay. So if you want to go ahead and mute it, but I am going to draw some pictures to kind of go with each one so we have some idea what this might look like. Okay. So if you want to hit pause and write the definitions down, leave some room for pictures, and then hit play when you're ready to go, and I'm going to start doing the pictures. Okay. For base angle theorems, we're talking about the relationship between sides being congruent and then having a relationship between angles. And this kind of has to do with isosceles triangles and equilateral triangles. Now, isosceles means that you have two sides that are congruent, okay? And equilateral means all sides are congruent, okay? Right? So, and we could draw this stuff a couple different ways. For an isosceles triangle, you could have a triangle that sometimes looks like this, and these two sides are equal, okay? You could also have an isosceles triangle drawn this way, and typically it's going to be a right triangle where these two sides are going to be congruent. So that's what isosceles means. And what it's saying is, if two sides of a triangle are congruent, then the angles opposite them are going to be congruent. So it's like you draw an arrow from this side to the other angle. This angle would be equal, and I do the reverse. I draw an arrow that way. So that means that those two angles have to be the same. So that's a base. Those are based angles. Okay. Same thing here. If I drew an arrow this way to the other angle or opposite angle, that would be congruent, and I draw here to that one, this angle would be equal. Now those aren't bases. That side is not a base of the triangle, but they're called base angles. They'd be congruent. Okay, so that's what the definition is kind of saying for isosceles. For equilateral, you would have a triangle that all three sides were the same measure. So therefore, if all the sides are equal, then all the angles would have to be equal. That's just, I don't know for a lot of us if that's kind of common sense, but that would make sense if you're doing that. It's the only way you could draw a triangle like that. Okay. All right. In the second box, if two angles of a triangle are congruent, then the sides opposite them are congruent. So this is kind of it's the converse of this one, right? If you draw this one, okay, you draw it this way. If these two angles are equal, then the opposite sides are going to be equal. Okay, so it's kind of the converse of what we just did. So if you had a right triangle, and if these two angles were equal here, then the opposite sides are going to be equal. Okay. So, just some stuff that really comes into play here. I think I kind of mentioned this in one class. I'll just say it again. The stuff that we've been doing in this chapter dealing with triangles, this is really an engineering thing. And, structurally, triangles give a lot of strength to structures like bridges or buildings or homes. Triangular shapes are built a lot in being able to disperse weight amongst, in a building when you frame it, or when you put a truss up, or when you're building a bridge, you're doing the under part of the bridge, and then you're going to build a road on it, on top of it eventually. Structurally, building a bunch of triangles in that structure allows weight to get distributed, therefore it's going to be strong. Okay. So all this stuff kind of goes with some engineering stuff. Okay. this last box down here, if a triangle is equilateral, so that means equilateral, all three sides are equal, then I can say that all the angles are equal. And so that's equiangular, okay? And then the converse of that is if all the angles in a triangle are equal, then I can say it's equilateral, all the sides are equal. So just the converse of itself, not a huge deal there, okay? But one thing I will say for this, if in this equiangular, equilateral situation, when you have that, if all the angles are equal in a triangle, remember a triangle is 180 degrees. If all the angles are really equal, then all the angles should be 60 degrees. Okay, so that's just another little footnote you need to have for that theorem. Okay, if you go ahead then, taking all this into consideration, if you could draw this figure, label it up, and we'll kind of go there with that. And they're going to ask us to find the value of x and y, which are angle measures. They don't put the little degree symbol there. They should have. Let's see if I can do it without messing it up too much. I'm trying to find those angle measures, all right? And we're going to take these theorems that we just did and kind of apply them. And, you know, the first information here, first off, this is really three triangles in one, okay? I have the big triangle. And then that big triangle with this line right here is being cut into two other triangles, okay? One of the triangles that gets cut into, if I look at what they give me here, that means that those three sides are congruent to this little small triangle on the left. So if all the sides of the triangle are equal, that means all the angles would be equal. And if you take my last little comment before we start here, if they're all equal, then they all have to be 60 degrees. Okay, so x would be 60 degrees. Okay, but I have to find y. But in this triangle on the right, you know, it's this guy right here. I'll outline a different color so we can see it a little bit better. In that one, this side is congruent to this side. Okay. And to me, it doesn't really look like it, but we're taking their word for it that they are. Okay, so if you take the middle rule that we had, or the first rule we had, the opposite angles should be equal. Okay, now if and a lot of stuff comes in here, just you guys got to really be on your toes and think. If you go back up here to the side of the big triangle here, that's a straight line. And part of that straight line is 60 degrees. So that would help me get this angle right here. Okay, so if a line's 180 and part of that line is 60 degrees, can't I do that? So I can get that this angle up here is 120 degrees. Okay, use that way. Okay. Now, kind of going backwards again, but you know, they said these are equal. That means the angles down here would be equal. Remember now, a triangle is 180 degrees. One of the angles that I know of is 120. So that gives me 60 degrees left over. But that 60 degrees has to be, you know, split between these two, because by the rule, the theorem, those two angles need to be the same because the sides were same. So I'm going to have to go and divide that by 2. And so that means each angle is 30. So that means y is 30 degrees. So that's a test question right there. It'll be a really good one for you guys to revisit. Make sure you got that down. We play lots of games with it, but it's pretty much you're going to get the same answer on those. So I'm actually giving the answer to the test question too. Okay. All right, if you can go ahead and draw that for me, please, and label it all up. Okay. So even though these look tough, we kind of have to get ourselves stuck here with sticking with an equilateral triangle. So this is really a kind of a, it's not a triangle being cut, it's a quadrilateral being cut into two triangles. So this line right here is cutting this four-sided figure into two triangles, okay? But when it does that, it shows us here that these two sides or these three sides are all congruent. So that lets me see that each one of these angles down here for this is 60 degrees, okay? Now, you guys are going, well, what are you doing over there? Because they're asking me to find X and Y. Well, sometimes I got to go and do stuff to get what I need to be able to get the answers I need, okay? So I take the obvious stuff, even though it might not be what I need. The other thing is down here, this angle right here is right. Now, that angle is really divided into two angles. This one I just found is 60. So that helps me find that this one should be then 30 degrees, so they add up to 90. Once again, that's not an answer I need, right? But now, what I'm being told here is that this side and this other triangle, this side and this side are equal, so the opposite angles should be the same. By the theorem we just learned, well, I got this angle already, it's 30 degrees. So that must mean that this other angle over here has to be the same. So X is 30 degrees. Okay. And in a triangle, so this triangle kind of over here on the right, the triangle's got to equal 180. Well, now I've got two of the angles and they add up to 60. When I subtract it, it gets me the third angle, which is this guy up here at the top. It should be 120. Oops, 120. So y equals 120. Goes same answers we got in the question above, but a different figure, okay? Or a different way that we kind of showed it, but it is a different figure, okay? So we kind of, stick ourselves a little bit when we give this question to you guys, because if we give you this equilateral triangle, it has to be 60 all the way around. That kind of helps you a lot, but you got to remember that rule and then apply it. And we applied it in two different ways. We used a straight line up here at the top to be able to help us. And here I used equilateral and then a couple other rules to be able to get the other measures, okay? All right. So that was 4.5, pretty short, couple really important rules though, so please make sure you go back and take a look at those, make sure that you're doing a good job with your classwork, and get a hold of me if you have any questions. All right, thank you.